Hi, welcome. In this video, we will solve problem combination sum asked by companies like Amazon, Microsoft, Facebook, Apple, and some others. Now let's check one more variation problem on backtracking, that is combination sum. Okay, this is one of the variant that we have in generating subsequences. Okay, this is one of the variant. Let's see. So we have combination sum given an array of distinct integers. Okay, so here you can see these are the arrays of distinct integers and a target integer is given. So this is my target integer and we need to return the list of all unique combinations. Remember, unique combinations, okay, of candidates where the chosen numbers sum to the targets. So basically these numbers will sum to the target. Okay, I will make the sum till target, but there is one condition. Okay, we need to return the combination. So you can see this is one of the combination, this is one of the combination, but the same number may be chosen from candidates in unlimited number of times. Okay, that means you can take 2, then you can again take 2, then you can again take 2, then similarly you can take 3, then you can again take 3, you can again take 3. Okay, there are multiple times you can take any of the number. Okay, two combinations are unique if the frequency of at least one of the chosen number is different. So basically, let's understand everything by this example. So we have this array elements, okay, 2, 3, 6, 7, okay, and I want to create a target of 7. So I can take 2 2 times, so 2, then 2, and then 3 one time. This is one of the combination, okay, and one combination is basically I will take 7 only, okay, so that is one possible way, okay. So you can say like I can take 2, 3, 2, but that is not a unique combination. See, right? Two combinations are unique if the frequency of at least one of the chosen number is different. Here you can see this combination frequency and this combination frequency both are same. Alright, so this won't be considered. Okay, so only these two will be considered. Okay, so we have 2, 2, 3 and 7. Similarly, you can check this one 2, 3, 5 where we have target as equals to 8. Okay, so here what are the combinations? I can take 2 4 times, so 2, 2, 2. Okay, or I can take 2 one time and I can take 3 two times. Okay, and then I can take 3 and 5. So now let's see how we are going to solve this problem. Okay, so let's discuss this problem and let's understand. Let me create an array. So I have this as an array. So this is my array where we have 2, 3, 6, 7, and let's suppose the target is basically 7. Okay, so previously what we were doing, right, in generating subsequences, okay, generating different sums. Okay, so we have a choice here. Either we can pick it, okay, I can take it, or I won't take it, right? I won't take it. Similarly here, I can take it or I won't take it. I will take it and I won't take it. So what was the function called? How was my function called? So basically, if you can remember, let's suppose GSY is my function call. So there were two values. Basically, if I am generating sum and I have index. So right, this was my function. So how I was doing the function calls, okay? If I am picking it up, right? So call was like this, that I am simply checking my function. I am simply adding into the sum, okay, sum plus array I, okay, and I am moving my index. Index will be index plus 1. Similarly, the next function call when I was not picking it up, okay, then I was not updating my sum, but I was moving index plus 1. Okay, so now you can see in both the cases I was moving ahead. Okay, that is not the case here. If you have picked one, okay, you can again pick it. You can again pick it. That's only the difference is here in this problem. Okay, so basically what will the problem here now? So suppose if I just simply do the same problem here, so now the things will be, suppose you have sum and you have an index. Okay, so you will take that, okay, sum plus array I, okay, and you will simply remains at that index. But suppose if you are not taking it, you have not taken this element 2, then there is a condition that you need to move. Okay, if you are not taking it, then I will move. So I will simply say sum and then I will say index plus 1. So when I am taking it, I won't move because I will simply again and again calculate the same sum. Again and again calculate the same sum. That is the only change here. Okay. So I hope now you are clear with this, basically how we are going to proceed with it. Let's see few more things that we can do basically our function. So what will be the parameters of our function? Like, so here you can see, I just want one sum basically that will add up, and I can simply move with the indexes. But here, because I want to store the different combinations, so I want some data structure basically where I will push my answers, right? Push my combinations. Okay. So I will be requiring one data structure where I will push my combinations. Also, you can do sum plus, basically you can do sum plus array, or you can go with your target and you can simply do target minus array. Okay. So if you are doing sum plus array, you need to stop when sum is equals to target. If you are doing target minus I, you need to stop when target is equals to. Okay. Both cases will give you the answer. Okay. So now let's do one of the dry run. Not dry run, basically we will do one function calling and let's see what are the different behaviors we will get, and then we will constitute our code. Okay, that is from where we will get the intuition. So let's see. So let me take an array. So I have this as an array 2, 3 and 5. Suppose these are my indexes. Okay, and I will do a one function call. Okay, let me put it here and let's start doing function calls from here. Again, for this one, the target, suppose the target is again 7. Okay, so if the target is 7, what will the different combinations possible? Again 2, 2 and 3, and here 3 and 2 and 5. Okay, these will be the two combinations. Let's see them. So basically I will have one function call. In that function call I will have the target. So can I say I will have 7 here? Let me first put the parameter so you will get the idea. So I will have the target t. Okay, then I will move with the index and I want one data structure to store it. So let's suppose I am simply taking answer as my data structure. So my answer is basically an empty array. Okay, now let me create it with the values so that you will get it. 7, index is 0. I will first call it this, and my answer is with an empty array. Okay, now I have a choice here again. I can pick it or I can not pick it. So what I will do, I will pick it. Okay, first choice will be pick it. I will do with the first one. Okay, I will pick it. So if I am picking it up, what I will do, I will subtract with my target. So 7 minus 2 will be 5. Okay, because I have picked it, I won't move ahead. I will simply add 0, right? But because I have picked it, I will push into my answer. That means I have picked this one. Okay, now again I can pick it again it. So I will do one more function call. Okay, and then the value will be 3. Okay, again at the same index, and now 2 again will come here. Again I will do the function call, right? So the value will be 1. Okay, again I am at the same index and it will be 2, 2. Right, now can you see that if you are going to take 2, will your target will become 0? It will become less than 0, right? This one. So what you can do, you cannot pick 2, because if you are picking it 2, right, it will decrease your target. Basically target will less than 0. T will become less than 0, right? So you need to choose wisely. If your array element, okay, is going to be greater, lesser than equals to target, not greater, lesser than or equals to target. Okay, now you can see 2 is greater than the target, so you won't take it. Okay, that the smart move you can do here, right? Otherwise you can take it as well, right? Target will become less than 0, and in that case you can simply say return from it, right? So whenever your target is getting less than 0, then in that case you can return from it. Or you can put one condition, if condition, that if your array I is less than equals to target, then only you are going to call this function. So from here you won't take 2, because it will basically not going to give you answer. It will make your target less, okay, less than 0. So you won't take 2. Okay, So now what you will do, you will move ahead. The only next choice is you will move ahead, okay, and you won't take it. Basically, you not pick call. So in not pick call, the target will be same, but the index will change, right? And when you are not taking it, so you will be at the same with the same array. Right? Okay, now you are at 3, index at 3. Now again you have a call. Will you take 3? No, basically again area is not less than equals to target. So you won't take this call. Again what you will do, you will move ahead, right? So target will be same, index will be 2, okay, and your array will be this one only. Now again, right, you have a condition that will you take 5? Because if you are taking 5, again target will become less than 0. There is no need to take 5. Okay, so you won't do this call and you will again move ahead. Right, so you will move ahead and you will have this one. Now once you moved ahead, you are at 3, right? And we can say we are reached to the end, right? So can I say, right, this will be my going to be my base condition when my index base condition, what will be when index is equals to n, can I say I will return from it? Yes, so what I will do, I will return from it. Basically I will return from it, right? Now this function is done with the 2 calls, right? So I will return from it as well. But this function is also done with the 2 calls, so I will return from here as well. This function is also done with this call, so I will return from here as well. But now you can see, right, here you return the value is same, here the value is same, here the value is same, but here the value is decreased. You have 2, right? So see, the thing is when you are taking this, when you are taking that call, you will say, suppose your answer is this is your answer array, so you will push it. Okay, let me put it here, that there will be 2 things. When you are doing a function call, it will be answer dot push the array I, because you are taking 2. You have taken 2, that's why your target sum is decreased now. So you are taking 2, it will be answer dot push I. But when you are reaching it back, okay, now you want this state. So what you will do, you will do pop it. So here answer dot pop you will do. Basically you will remove it, right? So this is backtrack, because you are backtracking to that position at the same state. The state should be same. Okay, it's more about the state. Okay, the state should be same. Okay, so now what you will do, now you have done with this call, you will do the next call. Then when you will move ahead, you will move ahead with the same target. So target is 3, but you will move with this index 1. Okay, and you have 2, 2. Now again you have a choice, will you take 3? Let me use this. You have again choice, will you take 3? Yes, you can take 3. Okay, so what you will do, you will take 3 and you will get 0 here, and index will be 1 because you can take it multiple times, and this will be this one, your array. Now can I say once you are at the 0, there is no need for the further calls, right? So one of the base condition also I am getting, whenever my target is will become 0, I will return from it. Yes, so here my target is 0. What I will do, I will simply store this answer. So I will store the answer somewhere. Okay, I will store it, but I will return from it. So I will return from it. Once I will return, now, right, I have here this pick call, right, this pick call. So where is my not pick call? So I will do the not pick call, where I have not pick it, and I will move with the index. I am at index 2. Okay, and this is my data structure. Now from here, this function, again I have a pick and non-pick call. So will I pick 5? No, because it will make my target less than 0. So I won't pick it, and I will again move ahead. So if I'm moving ahead, it will be 2, 2 with this one. Now can I say I reach to the my third index? Basically third I index is equals to 3. So that is the last. So I will return from it, right? Then this is done. This function also done with the 2 calls. I will return from it. This function is also done with the 2 calls. So I will return from it, right? Now this function is also done with the 2 calls. I will return from it, and see, whenever I am returning in the same state. 2222, right? 22, because here I have not pushed it. So that means also true. You are pushing only when you are taking, when your target is decreasing. When you are not taking, you are not pushing it. Okay. Now from here, you will take the not pick call and you will come here 5-1 with 2 value. Again, you have a chance that will you take 3? So yes, you will go ahead, you will take 3. So if you are taking 3, you will get 2, then 1, and it will become 2 comma 3, right? Now again, basically here you will have one further call. Will you take 3? So now you won't take 3 because this will make it less than 0. So you won't take this. Now you will move ahead, right? Next call will be you will move ahead with 2 comma 3. Now again, will you take 5? No, you won't take 5. You will move ahead, and once you move ahead, your index will be 3. I'm not writing here. My index will be 3, and again what I will do, I will return from it. So basically this function is done with 2 calls, this function is done with 2 calls, right? And here basically I have done only 1. So I will return here, but here one more call will be done, and that call will be when I will not take. Here I have taken 3, when I'm not taking it, so I will move ahead with the 2. Again I have a chance that I can take 5. So yes, if I am taking 5, it will be 0, right? With 2 same index, right? And I have 2 comma 5. So again, base condition is hitting, right? What I will do, I will simply return from it. Then there will be one more further call, right? I am not creating it. So you can simply understand. I will simply return from it. So here I will return from it, okay? And now I will return basically from it. Now again here, from here I can do the function calls similarly. So these are my possibilities basically that we can do here. And now see, right? I hope you got few of the things. First of all, whenever you are taking it, you will push it. Whenever you are coming back of it, you will pop it. Okay, we got our index equals to n, that is a base condition. We got whenever target is equals to, we got return condition. Okay, so I guess we have very good stuff to make the pseudocode now. Okay, so we are good to go to move to the pseudocode. Let's quickly create the pseudocode. So now let's create our function. Suppose basically this will be my pseudocode. So what I will do, I will simply suppose my function name is gsum. Okay, you will see like why I have written such a weird name, but suppose that's a gsum. Okay, target is t. Again with the same value, we have index and we have an answer. Okay, now this will be complete here. Now whenever if my k is equals to 0, what I will do, I will simply, because we are hitting that condition, so what I will do, okay, I got the answer, so I will take one res. So you can take one res array, okay, and I will push my answer. So basically in my res I will push basically my answer, okay, whatever my answer is. Okay, remember when you are creating, when you're pushing it, you need to push it such that their shallow copy won't be created. Basically it should not point to the same reference, because my answer will get to change by these states, right? So you need to push it by the, like, to create a new one. Okay, and then what I will do, I will simply return it. Okay, then the next condition, next base condition, whenever my index is equals to my array dot length. Okay, what I will do, I will simply say return. I will return from it. Now there will be two function calls. Let me write it here. There are two function calls. In one of the function call, what I'm doing t minus index. Okay, and I will simply say same index and I will simply do answer. In one of the function call, what I'm doing, my target will be same but index plus 1 and my answer will be this one. Okay, now in this function call there is some condition that if array of the index, okay, is lesser than equals to target, then only I am going to call this one. Okay, and when I am calling this one, okay, when I am calling this one, what I will do, because I can call this one, I will come here
We'll say answer dot push, because now my answer will change, so answer dot push array. Okay, and when I will return from it, we'll say answer dot pop. So see, before function you are calling, and after returning from function you are popping it up. This will pop is basically a backtrack method. Okay, again this is the same function call, and basically this will be my function will run. Okay, I will simply call this function gsum, okay, with my target, whatever the target is, the index, and with my answer array, right? And in the last, what I will do, I will return res. Okay, basically we have already done this, right? How basically our tree will works exactly same is really the recursion stack, so I am not going to do a bit of dry run of it. Okay, but we'll see, like if there is a required, we'll surely do. Okay, now we are good with the pseudo code and we can quickly move to the code implementation. But before moving into it, let's discuss about the time complexity and space complexity. So see, when there are different, when there are single elements, like 2, 3, 6, 7, okay, and you have two conditions, pick and non-pick, right? But after that condition, you are allowed to take an element only once. Okay, so you can take 2 only once, then you need to move 3, you can take 3 only once, then you need to make it 6. So basically it will depend on like 2 power n, whatever the total number of size of the array, go like this. Okay, but here the things are a bit different. You can call 2 multiple times, right? So here the time complexity will be 2 power t into k, right? So where k is the average size of the array. Okay, again basically here the time complexity is not that asked. Why I'm saying t, okay, not n, or why it is so hypothetical. It's basically suppose you have a single element of 1, okay, and you have a target sum of 20, okay, or 30, or suppose you have two one elements, right? So in that case one can be go one call, then again one function call. It is not depending on the length of the array. No, it's not depending on the length of the array, it's depending on the target sum, right? And it will do function calls till my name, till I am not hitting the target sum. Okay, so it's not depending on the n. So the basically the if you are asking about time complexity, it will more be exponential. Okay, and it's directly proportional to basically your minimum element, right? What is your minimum element? Okay, and what is your target sum? Okay, so target sum according basically it is directly proportional to your target sum, inversely proportional to your minimum element. Okay, okay, if there is your element value is very less, right? Very less, then there will be more function calls. If the element is value is higher, right? Suppose you have 10, then there will be less number of function calls. Okay, so yes, a bit complicated, but you can understand by this one. It's dependent basically your minimum element. It's inversely proportional, right? So if I'm taking 1, there will be high number of function calls. If I'm taking 20, there will be single one function call. Okay, so again this will be exponential, you can say. And similarly time complexity will be this one, and space complexity. So again there is no idea where the auxiliary space will be. Okay, because again the function, if the sum is 20, right, and the minimum value is 1, right? So again if I have my minimum value 1, function calls will be more, and if function calls will be more, auxiliary space will be higher. So again it is directly proportional to t by m, where t is the target sum and m is the my minimum element in the array. Okay, and if we talk about the space that we are using, basically the key different combinations, so that we can conclude as like again there will be different combinations, right? 1, 2, 3. So x will be the combinations, right? And into k, where k is the average size of the array, right? So time, again, that is also hypothetical, but this will be the space complexity apart from the auxiliary space complexity, right? So this will be the time and space complexity of this problem. I hope you are clear with it. In the next video, I will give you a quick code implementation of this problem, and then we are good to go with this problem. Okay. Yeah. So let's check out the next code implementation of this problem.